Hello, welcome to this freshman courses for BSc students, which name is Basic Mathematics for Natural Science students. My name is Nutukuta Shaga. I will be teaching you this course. Dear learners, welcome for this audio video presentation. Stay home. As you know, our world is now a pandemic, which call it coronavirus or COVID-19. So this audio video presentation helps to you learn by yourself. And this course have 4 chapters mainly. The first chapter is called Propositional Logic and Set Theory, and this chapter have 4 subtopics. These are the following: Propositional logic, open preposition and quantifier, argument and validity, the concept of set. And these chapters have its own learning objectives. By the way, students, after completing these chapters, you will able to define what does it mean open preposition. You will be able to differentiate the two type of quantifiers. You will be able to define argument or logical deduction. You will be able to identify hypothesis and conclusion of a given argument. You will be able to determine the validity of an argument using a truth table, and you will be able to explain the concept of set, identify operation set, and illustrate set using a Venn diagram. So, for icebreaker, by the way, are you a logical person? And what are the criteria to be a logical person? We hear in our community, oh, he is a logical. Oh, he is not a logical. What are the criteria, students? Evaluate yourself. Are you logical? If not, please give attention for these chapters and evaluate yourself after the end of this course whether you are logical or not. Topic 1, Propositional logic. We'll see here. What does it mean, logic, first? Logic comes from the word logos. I think this word is come from also Greek, which means reason. And it is concerned with the method and the rule of correcting thinking. First, let us see what does it mean, propositional logic. By the way, there are different types of logic. Propositional logic is the study of preposition, that means true or false statements, and the way of combining them using a logical operator. Here, also, we use algebra. The variable stands for unknown preposition, and the operators are and or not, implies, and if and only if. Means the variable not stand for real numbers. For example, in high school, x plus 2 is equal to 5. The x represents a real number, but here we use some variables. The usual variables to represent preposition or statement is p, q, r, and s. Dear students, preposition and statement have the same meaning. We can use interchangeably. Some books use statement and others use preposition. In this presentation, I will use a preposition, but they have the same meaning. The operator and or not, implies, and if and only if are called logical operator. Here we cannot use the usual operator, that is addition, subtraction, division, and negative. So first, let us define what is preposition or statement. Is a declarative statement that is either true or false, but not both. But not both at a time. For example, every cow has 4 legs. Riyadh is the capital city of Saudi Arabia. 1 plus 1 is equal to 2. 2 plus 2 is equal to 3. These are some of some sentences which are statements. Let us see the following, not prepositions. What time is it? X plus 1 is equal to 2. Answer this question. They are not a statement. Means their answer is not either true or false. Either true or false. By the way, using a logical operator, we get any preposition. So, any preposition which are formed using the existing preposition using a logical operator is called compound statement or preposition. So, let us see the first logical operator, that is negation. Suppose P is a preposition. The negation of P is written as like this. And meaning not. So it is not P. When we see the truth table, if the first statement is false, the negation of that statement is true. The reverse is true. For example, today is Friday. If this is P, the negation of P will be easily we can say it is not Friday today. Today is Friday, or today is not Friday. We can use either of the two. Conjunction. Suppose P and Q are two prepositions. The conjunction of P and Q is written like this. By the way, conjunction means and. So the preposition P and Q is written as P and Q like this. When you see the truth table, here, since we have two statements, we have four possibilities. That is, they may be the first. They may have the value of truth value, false, true, true, false, and true. So here our objective is finding the new compiled, which we call it a compound statement, truth value or truth value. So false and false is always false, false and true is false, true and false is false, true and true is true. So simply to handle it, simply we will get a true compound statement if both are true statements. So example, P is today is Friday, Q the preposition says that it is raining today. Now let us write in English. It says since today is Friday and it is raining today. Now this preposition is true on rainy Fridays. That means if the day is Friday and at the same time as that day if there is a rain. But it is false on any day that is not a Friday or a Friday when it does not rain. So this is a best example. For example, let us see 2 plus 2 is equal to 4 and Q 3 times 4 is equal to 7. Now P and Q written as so here we get another statement which call it R. Like for example in high school algebra, 3 times 3 is equal to 9, or 3 times 4 is equal to 12. 3 is number, 4 is number, we get another number by 4. By the way, 3 and 4 may have different answers using what? 3 times 4? 3 times. 3 minus 4 minus 1. Why is the answer different? Because of what? The operators. So 3 times 4 is equal to 7. 3 is number, 4 is number. Using operator, we get another what? Number. The same fashion is here true. That means we have 2 plus 2 is a single statement. 3 times 4 is also a single statement. That means it has its own truth value. Q also has its own truth value. So we generate another statement, that is 2 plus 2 is equal to 4 and 3 times 4 is equal to 7, and our objective is finding the truth value of this compound statement. So for this we can use a truth table of this. So the first one is true, the case rating. The second one is false, means 2 plus 2 is 4 is true automatically, and 3 times 4 is 7 is false, so true and false is false. So what is the truth value of R? False. That is our object. The third one is disjunction. Disjunction means of. Suppose P and Q are prepositions. So the disjunction of P and Q is written as like this. The preposition P or Q is written as P or Q, and the truth table is here. Since there are two statements, we have four possibilities. False or false is false, false or true is true, true or false is true, true or true is true. So here we will get the false value if both are false. Here are examples. P is the P is preposition. It says that today is Friday, and Q, it's raining today. So when you write this, today is Friday or it is raining today. So the new preposition or the compound preposition is today is Friday or it is raining today. Now we have to consider as a single statement. That means it will have what? One truth value, with either true or false. So this preposition is true when on any day that is either a Friday or a rainy day, including rainy Fridays, because true or true is also true. It is false on days that are not Friday, when it also does not rain. It does not rain. Am I clear, my students? For example, let us take a simple example, mathematical examples. 2 plus 2 equals 4, 3 times 4 is equal to 7, P or Q written as like this. So true or false is true, because the operator is disjunction. And here are some additional examples, you can observe it. And the fourth one is implication. Suppose P and Q are prepositions. So the conditional statements, the implication, which written as like this. But some books may use a double arrow, but they have the same things. So P like Q is P, so it reads like the following: if P then Q, if P then Q. From here, the first part or the first statement which comes after if, which call it hypothesis or premises, and then the next statement is called conclusion or consequence. By the way, it's very important truth table. Now, if we have false implies false, the truth value is true. False implies true, true. True implies false, false. True implies true is true. Now here is, in order to understand the truth value of implication, we can get the false compound statement if the first one is, or if the hypothesis is true and the conclusion is false. This is only chance to be get what? A false compound statement. The others are false, by the way. I mean, the others are true. The others are true. Example: Ahmed learns discrete mathematics. Ahmed learns discrete mathematics. The next statement: Ahmed will find a good job. Then when you write P implies Q, if P then Q. If Ahmed learns discrete mathematics, then he will find a good job. Now, this preposition is false only when P is true and Q is false. Otherwise, it is true. Let us add one example. Today is Friday. Q. 2 plus 3 is equal to 5. Then, when you write P implies Q, if today is Friday, then 2 plus 3 is equal to 5. This preposition is true because of it is what? Conclusion. We don't bother about today's Friday. If it is true, true implies true is true. If it is false, means if it is not today's not Friday. So false implies true is also true. So it is true because of the conclusion. We know that 2 plus 3 is 5. 2 plus 3 is 5. Let us see these three terms: converse, contrapositive, and inverse. The conditional statement or the implication P implies Q. If it is raining, then the home team wins. So, if you are given P implies Q, if you make it negation Q implies negation P, it is called contrapositive of P implies Q. And if you make it Q implies P, it is the converse of P implies Q. And if you make it negation P implies negation Q, is called inverse of P implies Q. So, what is converse? What is contrapositive? What is inverse? Means like this. Like this. The last one, logical operator, is called bi-implication. Suppose you have two statements. As the name indicated, bi means two implication. There are two arrows on the side of Q and on the side of P. So let us see how to read it. Look, we denoted a double arrow. P arrow Q is read as P if and only if Q. It is true, both are true. By the way, this means, now look, P by implies Q means, first, go ahead, starting from P to Q and Q to P. So these are what? Equivalent. They are equivalent. If this is true. So, to simplify our work, let us use the truth table. False, by implies false, true. False implies, by implies true, false. True by implies false, false. True by implies true, true. So, as I said before, P implies Q has the same truth value. Look, this is P by implies Q, true, false, false, true. And P by implies Q means P implies Q and Q implies P. Look this. Now, these are true, true, false, 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 true, true. They are equivalent statements. They are the same. They are the same. Let us see examples. You can take the flight, the first statement, and the next one is you buy a ticket. P by implies Q is like this. You can take the flight if and only if you buy a ticket. This preposition is true if P and Q are either both true or both are false. Here, the precedence of logical operators. Do you know, by the way, in algebra, body mass, brackets, multiplication, and like that? Like this here, first we have to manipulate negation and next and or implication and by implication. These are the orders. Okay, how we form a truth table for a compound statements? compound statements. In order to construct a truth table, we have to use the formula to the power of n. N stands from number of letters or number of statements. For example, this, let us construct the truth table of this. How many letters here? Don't count the negation of the letters, simply count the kind of letters. Here is P, here is Q, to the power of 2 is equal to 4. So we will have 4 lines. These are the first row, the second row, the third row, the fourth row. So in order to write a value of this, we have to be systemized. We have to use a system. 2 the power of 2 is equal to 4 over 2. Why I divide 2? Because one statement may have a chance to provide either true or what? False. So first for value of P, give false, true. Next 2, you get here 2 over 2, 1. That means 1 false, true. False, true, false, true. These are the initial ones. So you don't bother about the negation of Q, because if you know Q, you will get using this the previous logical operator, you can find the last truth value of a compound statement. For example, if you have 3 letters P, Q, R to the power of 3, it's not 6, it's 8. You may have what? 8 lines. 8 lines like this. The first, the second, the third, the fourth, and it continues 8 lines. So 8 divided by 2, it will be what? 4. That means give for P 4 false, 4 true. Next Q, 4 divided by 2, 2. 2 4, I mean 2 false, true, false, true. And the last one, 2 divided by 2, 1 false, 1 true, false, like that. Then you have to evaluate based on the given logical prepositions. By the way, what is the application of this? If you are electrical electronics department students, if you are a student of electrical electronics, do you know a gate, a logic gate, and or gate? For example, like let us see this analogously. For here, 0 represents false value and 1 represents for a true value. By the way, I think in the previous we have seen false or true is what? True. Here 0 or 1 is 1. By the way, here false or false is what? False. Is the same. 0 or false, 0 or 0 is what? 0. When it comes to AND gate, false and true is false. Is the same is true. So this is the application of one of the application of logical operators. And next, let us see what does it mean tautology and contradiction. A compound preposition that is always true is called a tautology. Means after we construct a truth table, if the last column of the compound statement value is true, we call it that is tautology. For example, this is a tautology. Whereas a compound preposition that is always false is called contradiction. we may get a compound statement which is neither tautology nor contradiction, which call it contingency. And the next one is propositional equivalence. Compound prepositions that have the same truth value in all possible cases called logical equivalence. Means, after constructing a truth table, if the last column of the first compound statement and the last column of the second compound statement match by truth value, then we call it the two compound statements are called logical equivalent. And it's denoted by like this. By the way, it is not a logical operator. It is not, rather it indicated a kind of logical equality. For example, let us prove that the negation of this is equivalent to this. So, using a truth table, by the way, here, how many letters? 3 letters. So, to the power of 3 is what? 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. For the first P, you will give what? 4 true, 4. You can start from false or side. Doesn't matter. But if you start here false, you have to start also for the second statement the same fashion. If you start to true, you have to start for Q true. If you start for P false, you have to start for Q false, like that. Now, these are the final answer. For example, here, the first is false. Also, the second, for the first compound statement, for the first row is false. Also, for the second compound statement is false. Look, the red one. False, true, false is the same. So, we can call it these two statements. That means this one and this one is equivalent compound statement. For example, there are some equivalences. Identity law. By the way, what does it mean identity? In algebra, for example, in addition, when you see in addition, 3 plus 0 is what? 3. 4 plus 0 is what? 4. 5 plus 0 is what? 5. 0. So, 0 is additive identity. Like here, look, P and true is equal. Identity law says that P and true is equivalent to P. For example, P may have two possibilities, either true or what? False. Let us take the true value. True and true is, we know that true, that means P and true is P. So by analyzing this, you can increase your understanding. So these are called identity laws, domination law, component law, double negation law. By the way, what is the negative of negative 3 is what? 3. Like that, the negation of negation P is also P. So these are some laws. De Morgan's law, these were very usual laws. It says that like this, so please read it and understand. If you have any question, please drop your question per my email. I put my email as the last slide. So, also there are another propositional equivalence. For example, using De Morgan's law, express the negation of, look, Ahmed has a mobile and he has a laptop. From here, the P and Q, when you take out P and Q, Ahmed has a mobile, Q, Ahmed has a laptop. So these are what? P and Q. Now let me back again what De Morgan's law says that. It says that the negation of P or Q is equivalent with the negation of P and negation of Q. At the same time, the negation of P and Q is equivalent with the negation of P or the negation of Q. So let us come to here. So look what I said earlier. What is the negation of P? Ahmed is not a mobile. Ahmed has not a mobile, sorry. The negation Q, Ahmed has not a laptop. So write this. Negation of P, Ahmed has not a mobile or he has not a laptop. Their equivalence means their truth value are the same. Their truth value are the same. Here I put an activities which help us to understand the above presentation, and we will continue topic 2. Thank you for watching. In the coming class or the next class we'll see open statement and quantifiers. For this presentation, thank you very much.